cleaned it up. How do I clean this up? First.
Oh, can I divide by 1500?
Absolutely. Yes. My first step has to be dividing both sides by 1500. So then this is 2 equals e to 0.0208 times t. Excellent. Now we want to stop for a moment and review the properties of logs. So let's review the properties of logs, and then we'll come back. The properties of the log function in any base, of course, in any base. There are three. Anyone remembers any of the properties of the log?
Natural log, and I forgot the rest of this.
Log applied to a product. Log applied to a ratio. And log applied to a power. These are the three properties of the log. There is an additional one of change of base. I call this a formula. We're going to review all four. Okay, so the first one. When we apply log to a product in any base, doesn't matter, it's a sum of two logs, individual logs. Log of A plus log of B. This one is the same, but with minus. Of the top minus the bottom. And this one is the one that you already told me to apply, but I wanted to review all of them and put all of them together. This power goes in front as a factor, not plus or minus, multiplied. B times log A. Last one before we come back is the change of base formula. So if I have, let's say, log base 30 of 21, no one can do this by hand. So it equals two different options. You can use, yes, the sophisticated calculators, you can plug in the base and you can plug in that number and you get the answer. But let's talk about the change of base formula. Assuming that I only have these two in the graphing calculator, log, which means base 10, natural log, which means base e, this is what I'm going to use. So this is log of 21 divided by log of the previous base. Same thing, but with natural log. 21, natural log, 30. Notice that this is not this. Here, log is applied to a ratio. They're not the same. This is a ratio of two logs. So do not confuse these two. Again, the first one says log is applied to a ratio. This one says this is a ratio of two logs. Okay? So how do I determine this? It doesn't matter which one I use. I use either log 21 divided by log 30. And I get, in both cases, I get the same answer. So it's approximately 0.8951325536. And how do I check? When I raise 30 to this number, I have to get 21. If I raise 30 to this number and I don't get 21, this is wrong. So then 30 power previous answer. Don't type up anything. Previous entry. No, I didn't mean that. I meant 30 power previous answer. I'm going to do it with the calculator so you can see it better. When I hit enter, I have to get 21. If I don't get 21, this is incorrect. So that's how we check. Perfect. Now we're ready to continue. Which of these properties is applicable now. And it is applicable. Yes? Yes?
Those since they're gonna do natural log.
Yes, we have to apply natural log to both sides. Indeed. Excellent. This stays as natural log 2. But this one, the power goes in front as a factor. Yes.
So I would bring 0.208 t in front of e.
And now I'm going to write times. For what do we know about natural log e?
Oh, it just goes away.
Why does it? Why? Because it's what?
Their inverse.
What does natural log e equal to?
1.
Exactly. That's why I didn't even put it there. So let's add here. Natural log e is 1. Log 10 is 1. So it's the same base. Same base. If I have log base 17 of 17 is 1. And so on and so forth. So coming back to our problem, how do I get t? Dividing
by 0.2.
Dividing this by this. That's all I'm going to do. Natural log 2. And I divide by I better divide 0.0208. And that's the doubling time. To get at this slow rate of 2.8%, to make our 1500 turn it into a 3000, we need 33.3 years. 33.3 took 33.3 years. Good. Any questions? Okay, moving on. Let's we can look at some properties. If you'd like to choose any property from here, if you'd like to choose any equation from here, and this is extremely important part, 51 through 60. So any exponential equation that you would like to work on, or any properties that we use natural log, you know, it says use properties of natural logs to find each value, and they're giving us some values. I would like just to simplify, or whatever you decide. I am ready.
Number 58.
Yes, where is 58?
Oh, wait, no.
This one?
That's not what I was looking for, but sure, no worries.
No, I'm sorry. You said 50 or 40?
I said 50. I thought it was 58, but I lost myself. But yeah, we can do number 58.
No, I would like to work on an equation first, and then we can choose anything you want from the... Yes, we want to look at the exponential equation first, and then find domain of log functions. You can choose both. It doesn't matter.
Let's do number 49.
Okay, perfect. 49 it is. So I am on page, what is it, 7? Good. And we're looking at 49. So 200 e to 0.045t equals 600. This is identical to the situation we just looked at, but it's a good practice. Okay, we're asked to find t. What will be the first step? Mandatory step, actually.
Divide by 200.
Yes, we have to clean it up. So we have to divide both sides by 200. So e to 0.045t must equal 3. Next step. We always have to clean it up, because if I apply natural log to a product, I have to change it into a sum. It becomes more difficult. Doable, but more difficult. More steps.
Then we do the natural log.
Yes. Now we apply natural log. and we have 0.045t equals natural log 3. We didn't write natural log e because we know natural log e equals
1.
That's it. Perfect. Good. So
Now
then,
we
yes. So now we
now we divide by 0.45.
exactly. So let me also show here because it's easier for you guys to see. So we have natural log 3, close, divide by 0.045. And we get 24.41 approximately. That's it. Okay, now, yes, this is very important, from 51 through 60. Uh, 55,
50.
yes, go ahead. Which one?
I was gonna say 58.
55 and 58. So let's start with 55. So y equals natural log of x plus 3 plus natural log of 5 minus x. And I'm also copying 58. So g of x equals natural log of x plus 6 plus natural log x. Perfect. Good pick. Okay, I have a chat. Is the chat for me? Should I look? Perfect. Okay. So remember what we said. Is log a friendly function? Is log a friendly function?
No.
No. Very good. I was just going to go back, but you already answered. Now, before we look at this, something that we discussed several times, if I have the square root of 2x minus 1, what do I have to write to find the domain of this? And you can say, what are you jumping? You'll see in a moment why I'm talking and comparing to this in a moment.
Would it be parentheses 2x minus 1 to the 1/2 power?
We're talking about the domain.
Oh.
How do I find the domain of this function? Nobody likes.
Equal to 0.
Nope. It's a square root.
Greater than or equal to 0.
Thank you very much. That is always the condition. We discussed this several times. We can only take the square root from positive or 0. Excellent. But now, the reason why I brought this up is because for this function, I have to write x plus 3 strictly greater than 0. So they're kind of similar somehow. For this function, I have to write 5 minus x has to be strictly greater than 0 because otherwise, natural log does not exist. So I have to put these two together for this function. I have to write x plus 3 strictly greater than 0, and I have to write 5 minus 6 strictly greater than 0. So this means x greater than negative 3, but careful. This means x less than 5. When you move x here, x less than 5. Now we have to draw to see, maybe you can see it, or maybe you don't have to draw, but I will draw. Here's 0, negative infinity to infinity. This is from negative 3 to infinity. I don't care for units. It's very clear. And the other one is less than 5. Again, I don't care for units. What will be the domain of y then? We need both logs to exist at the same time. So then what will be the domain of y? Anyone would like to try? We had these situations before when we looked at domains of functions that had two radicals in them.
I want to say negative infinity to infinity.
Only, you can say only when both exist and when you see both colors. If you don't see both colors, you cannot pick that.
Oh, in that case, would it be negative 3 to positive 5?
Absolutely. That's why I said both have to exist at the same time. Here only one exists, here only the other, only here they both exist. Absolutely. So in the same way, we're going to look at 58. Can anyone give us the condition for the first part of 58? Let me copy 58 here one more time. So we have g of x equals natural log of x plus 6 plus natural log x. Can anyone tell us the conditions?
X can equal negative 6 and x can equal 0.
That's not what we did. That has nothing to do with what we just did. This is not a rational function. For a
Right,
rational function, that would be correct.
Sorry, x plus 6 is greater than 0.
That's a different story. Yes, I completely agree. Awesome.
And then x is greater than 0.
Brilliant. That's it. The quantity we apply log to has to be strictly positive. The quantity we apply log to has to be strictly positive. Awesome. So then this one is x greater than negative 6, and this one is x greater than 0. If you need to graph, do so. The first one is greater than 0. Fine. And the second one is greater than negative 6. I need to find the domain of G. Anyone?
0 to infinity.
That's it. I see both colors. They both exist. That must be it. Awesome. Great job. Great job. Good. I'm stopping this video and I'm starting